Welcome. In the past, I've done a number of videos teaching you Python, and part of using Python needs a database. And we started to talk about database creation and database use connecting to Python. I'm going to step back and introduce you to a number of videos dealing with SQL. So we're going to go back to basics and learn SQL. So I'm calling this SQL with Andrew. And I want to take you through a bottom-up approach to learning some of the basics of SQL. And I'm going to do it in a way where we identify some of the aspects that need to be thought out of for good, strong relational database work. But most of the time, we're going to be focusing on the language of SQL and how to get up and running very practically, very quickly in creating tables, inserting data, retrieving data, the sort of features you need of a database when you're going to attach it to your program. Whether it's Python or other programming languages, you'll generally want to attach to a database like SQL. Now, that's not to say that the SQL is just a bunch of tables in a database. It's much more than that. In fact, it's a very rigorous field of study. The whole area of relational databases and the constraints and the quality and the security that comes with it is fantastic stuff. And we'll learn about that as we go along. But we're going to sort of go from the bottom up and say, okay, what's a very basic table? And then learn the rest as we go along. So join me in this series of videos where we explore more about SQL. Now I'm going to jump over to my editor. And if you've seen any of my videos, you'll notice that I am using Visual Studio Code for Python and other languages, but I also use it for SQL because SQL is really just another language. And we're going to build, if you like, scripts, and we're going to build files where we can, if you like, manipulate a database and learn more about databases and connect them to a programming language like Python. So if you haven't set up Visual Studio Code, then I recommend you do. If you haven't set up the extension to allow you to use or create databases in MySQL, then I recommend you do. And if I jump over to my extension that I use, it's not the only one there, but the one I use, if I go into what I've got installed, let me show you what, where is my MySQL? I use this extension here in Visual Studio Code. I find it a very robust extension. It's got all the facilities I need on top of the editor, good syntax checking, good highlighting, things like that. And it's a good database client. It also works for more than just SQL. We can use other databases with it, which we will do in the future. So I like it. I also like staying within the Visual Studio Code environment because I'm familiar with it. So there's a lot to be done there. So my recommendation is install MySQL onto your computer. And there's plenty of videos to show you how to do that, very easy. And then in Visual Studio Code, if you're going to use that, then I recommend this particular extension, but up to you. What this extension does, and let me just get rid of that. Here's my file here, but I've got another tab here, the database, which will show me all the databases that I have and show me the tables as I go along interactively. Right, I've already created a database called inventory. It's not showing very well there. Let me see if I can drag that across. Inventory as my database, because today we're going to focus in on creating tables or the basics of creating tables. So set yourself up, get comfortable with that, install SQL, install the extension, create a basic database, call it inventory. It doesn't really matter. And then we'll be off and running. And I'm going to close this down because today we're not going to look too much at the database, but just look at creating a table. Now, the basic format of creating a table, the basic syntax is there in my comments. Create table with a table name, and then you have various columns and data types. And straight away, we start to see some of the power of SQL. Some people actually see it as some of the weakness, but I think it's some of the power. We need to add a data type to our column headings, if you like, so that we have those, if you like, constraints to our data, improving data quality, etc., etc. So if you think about what we're creating a table, if you think about it in Excel, and I had a column heading in Excel, let's say name, I don't have anywhere in Excel where I need to say that name is a variable or that name is a set of characters. It could be anything. And that could cause problems depending on how I use that table. So we do have that strength of SQL. It already starts to say, you better be very clear in what you want. So let's start off with creating a table, simple table called parts. Parts. And I'm going to give it, oops. I'm going to give it a name is my column name, and I must give it a data type. The easiest data type to use is varchar, and that means, and let me just put a number in there like 100. That means I want it to be characters, which can include numbers. Characters, it's like a string. The maximum it can be is the 100, but because it's called a varchar, that means we might reduce it in the database to whatever length you have, so that we save space. When I say might, we actually do. So name varchar is the simplest format of data type. It's a string. In programming languages, it's a string, easiest. And then let's have a price. Oops, keep doing that. A price as my variable, and I'm going to make that a decimal. All right. Now, I can use float. I can use other things. I can put decimal too. I'm going to keep it very, very simple at the moment. It is the type that we would expect. It's a decimal. Price is going to be $1.45 or 1.45. At this point is probably going to be 2 decimal points, but who's to say it might be more in different languages. So I'm going to keep it very, very simple because it doesn't really matter. I've said it's a decimal, and that's enough. And then I'm going to put my last one, stock, which is an integer. All right, and I'm going to close that. Oops, I'm going to close that bracket in. So that's a very, very simple parts table. It has a name, it has a price, it has a stock. You'll see at this point, I've given it very basic data types, and I have not used this constraint part, and I'll talk about that in a minute. I haven't constrained the actual values, if you like. Okay, so let me run that and see what I get. All right, it runs that bit of code, and it gives me that it in green, so it tells me that it did work. It would have gone in red if I had made some syntax errors or some logic errors, just like most programming languages do. So nothing fancy about that. Let me just delete that. And if I go to my database over here, you'll see I've got my parts database there. I can refresh. I've got my parts database there. And it tells me my data types there. Okay, so that's nice and easy. Nothing fancy there. Now, what I'm going to do is, because I'm going to, if you like, expand on that and add some constraints, some of the more useful constraints that we have, I'm going to drop that table because every time I recreate, if I try to recreate it here now, even if I made some changes, if I try to re-execute it, it'll give me an error saying it already exists. Okay, so that doesn't make sense for me to do it. So there is a way that I can fix that by going drop table if exists. Oops. Okay. Should have done that in uppercase. Okay. So if I execute that, it should delete the table, which is good. So it's actually always, if you're building a table and a database, etc., it's actually good to put this at the top line so that when you always, you're like, in case it's there, it'll sort of freshen it up, and then we can actually run that whole file. So we're building it interactively, but along the way, we're building, if you like, something that is meaningful that we want to use. So now if I run the whole file, it drops a table, and then I can create a new one, okay? And I can drop it again. So nice and easy. So let's just quickly talk about the different types you can have here. There's lots of different types, and I'm not going to go through them all at this stage. We will build them on them as we need. It is very important that you get a reference of the data types that you're allowed to use, because there are some changes. Number one, things like decimal versus float versus integer versus int. There's some changes that have changed with the language over time. The other thing to remember is I'm using MySQL. That is one version of SQL. If we were using SQL Server or using Microsoft Access, it would be a different set of data types. Similar concept, but different names. So you always need to say, what SQL language am I using? And what's the reference of all the data types that we have? And if I quickly copy, if you like, some of the ones that I find that are most used there, we've looked at varchar. Char would mean exactly that same size. And we've got integer we've talked about. We could change the size. Float, decimal, date and date time are very important when we want to timestamp records. And if we jump back up here, Boolean, sometimes used, most people use a character of 1 and say T or F or yes and no. This one here, enum, is, if you like, if you want to have a set of values that are allowable, like consumer versus trade, you can set up, if you like, values associated with that. And we'll do that as we build along. So I just want to show you that these are another handful. There's probably another dozen more with bigger size data types that have been introduced over time. I'm not going to worry about that at this point. I just want us to focus in on the basics, but I will introduce them. So make sure that you find yourself a good reference of the different data types of your SQL. So before we go, I want to just touch on one or two of the constraints that we might use. Before we start talking about primary keys and foreign keys and all that, I want to talk about this parts database. At the moment, we have built it and we've got no constraints on each row. We could put in a row called nuts, if you like, or bolts, $1.50 and stock, and we could put another one with bolts and another one with bolts. We could, if you like, duplicate the rows over and over. There's no constraints. That is not a good thing for an SQL database. SQL or relational database, if you like, theory starts to talk about unique rows. And the way it does unique rows is it either sets up what's called a primary key or starts to say that the constraint, if you like, of this varchar here is unique. Okay, so we can say that this variable is unique. And again, if I save that and I drop that and I've created a unique. So now if I tried to insert bolts as a record and then tried to do it again, it would say you cannot insert this again. So unique is one way of saying that it is not allowed to have duplicates, which is linked to a very important part of relational databases. Right. Now, when we talk about primary keys and when we talk about uniqueness, often we introduce a different variable called parts ID, and we'll call that an integer. Right. And we would say that that is not null and unique. Right. And so often we'll do that, not null, unique. I think I've got my, yeah. And what that means is we've introduced this new row numbering, which we're saying is an integer, so it can start with 1 and go all the way up to whatever number. And it must be a parts ID. You can't have a blank parts ID, and it must be unique. Right? That means that we could actually take away the constraint of saying the name has to be unique. So because there might be different types of bolts. Right? So in this case, I'm going to leave unique in there, and we might also say that integer needs to be not null. So again, we are starting to put constraints in. Now, there's all sorts of other constraints that we'll look at in a later video where we're going to set up, if you like, that this parts ID is really what's called the primary key. And then we might also have some checks on our price. For example, our price must be greater than 0. So we're putting sort of like some integrity checks on our data so that no one or no program is able to enter bad data into our field. The same with this price, we might say it's got to be not null. In other words, we must have a price. If we're going to stick in a part in the database, we must have a price. Now, we might choose not to have that because maybe we don't know the price. So sometimes it is unknown or sometimes it is null, but it's the more we can constrain it in our database, the better. Okay, so I'm going to leave it at this point to say here's a quick introduction on creating tables. You have a table name, that's easy. Then you have a list of, if you like, names or column headings. And each of those column headings needs a data type and may or may not have constraints. If you don't have any constraints, then your data quality or what could go into that table could be all over the place. If you really want to use the value of a relational database, you start adding constraints and you start structuring the data better so that you don't have, if you like, a mess of data. That's one of the sort of biggest strengths, although, as I said, some people might say weaknesses of an SQL database. As we go along, we're going to, if you like, be true to the SQL ideals and put constraints in and make it, if you like, a true SQL or true relational database as we build more and more tables. Okay, I think that'll do it for now. My recommendation is try create a few tables, set up your environment, try looking at the different data types. There are more than this. They're just the most used, and try and explore some of the constraints that I've put in there. Thanks again for watching. Remember, subscribe if you like what you're seeing, and also share this with anyone else you know that might be looking to learn more about SQL.